Have you ever pondered why magnets stick to your refrigerator? Or why compasses always point north? The answer to these intriguing questions lies in the fascinating world of magnetic forces. Magnetic force, in the simplest of terms, is an attraction or repulsion that arises between electrically charged particles because of their motion. Imagine two people dancing around each other, their movements causing them to attract and repel each other. This dance might sound complex, but it's the basic principle behind many everyday phenomena, like the action of electric motors and the attraction of magnets for iron. To truly understand magnetic forces, consider stationary electric charges. They're like people standing still at a party, exerting a certain pull on those around them. This pull is an electric force. However, when these charges start moving, they not only have an electric force, they also have a magnetic force. It's as if their dance movements make them even more attractive or repulsive to their partners. Now, how does one calculate this magnetic force? Well, it's quite simple, really. The magnetic force on a moving charge is proportional to its charge, the speed at which it's moving, the strength of the magnetic field produced by the other moving charge, and the angle between the path of the charge and the direction of the magnetic field. The force is zero if the charge is traveling in the direction of the magnetic field, and is greatest if it travels at right angles to the magnetic field. In other words, if two charges are moving in the same direction, there's no magnetic force between them. It's like two dancers moving in sync. There's no push or pull. But if the charges move at right angles to each other, the magnetic force is at its strongest. It's like two dancers spinning around each other, their movements causing a strong push and pull. To summarize, magnetic forces arise from the motion of electrically charged particles. These forces are responsible for various phenomena we experience in our daily lives, such as the working of electric motors and the attraction of magnets for iron. The magnetic force on a moving charge depends on its charge, its speed, the magnetic field produced by another moving charge, and the angle between its path and the magnetic field direction. So the next time you see a magnet sticking to your refrigerator or a compass pointing north, remember the invisible dance of charges that's happening right before your eyes and the incredible magnetic forces that make it all possible. It's these hidden forces that keep our world in motion in ways we often take for granted. Yet understanding them can open up a whole new perspective on how the universe works.